Hello guys, welcome to this counting sort video. In this video, I'll be explaining you how to do counting sort in a very easy way. Actually, there is a very easy method for counting sort, but we're not gonna discuss the optimized version. Will be discussing the traditional version of counting sort in this video. So um, let's get right into it. So let's say we have a array of random elements. They're not sorted. So let's say we have 2, 5, 3, 5, 0, 3, 1, and this array will call it as A. Now, what we want to do is we want to sort it. So our final output sorted array will be 0, 1, 2, 3, 3, 5, 5. So from array A, we have to go to array S. This is the whole sorting process, and there are a million sorting algorithms. Like a lot of research has been done for sorting elements, but as of right now, the best case time complexity of sorting we have achieved is n log n, and if we know some things about the data, we can some properties about the data, then we can achieve linear time complexity instead of n log n. Linear is big of n, and yeah, counting sort is big of n if I'm not wrong. Okay, so yeah, it's actually very simple. So what we do is we make a temporary array, temporary array, temporary. Okay, wait. Let me rename it. I'll call it a frequency array because that is what it is called in uh, competitive programming with general terms. So a lot of you might already know what a frequency array is, and the size of the frequency array will be the maximum, will be equal to the maximum element. So here the maximum element is 5. So the last index should be 5. So it will be maximum, the size will be maximum element plus 1. So 0, 1, 2, 3, 4, 5. So totally 6 elements. 1, 2, 3, 4, 5, 6. Or if you start from 0, you will get to 5. Now, yeah, I'll write the index also 0, 1, 2, 3, 4, and 5. Now we start traversing the array from the beginning. We see that first element is 2. So in the frequency array, we go to second um, index and we increment. Okay, a frequency array is initialized to 0. So by default, everything is 0 in this. So when we start traversing, we get 2. So we remove this 0 and we write 1 over here. So we're basically incrementing it. Then we go to 5. Then we reach 5. And so we go to the fifth index and increment it. And we keep doing this uh, till we have traversed all the array elements. So then we go for 3, then again we will get 5. So this time we already have 1. No difference, just increment it again. So this becomes 2. Then we get 0. So we go to 0th index and make it 1. Then we again get 3. So we go to 3rd index and increment it. Then we get 1. So we go to index 1 and increment it. So this is my frequency array. So now using this frequency array, I'll be making a cumulative frequency array, also known as C. The size of this array will be same. Basically, what we'll be doing is making a cumulative frequency in which the ith term is equal to ith index wait, ith term a of I. or wait, let me make it as C of I will be equal to its the addition of its previous element C of I minus 1 plus F of I. So using this will make the cumulative frequency array. So we just set the frequency. So this will be 1, then 1 plus 1, 2, then 2 plus 1, it becomes 3, 3 plus 2 becomes 5, 5 plus 0 becomes 5, and 5 plus 2 becomes 7. So now we have this C array. Okay, so I hope you this was the easy part. I hope everyone understood till here. Now it will get a little bit tricky. Now what we'll do is we'll make a array named B, and the size of the B array will be equal to the last element, the value of last element in C array, the cumulative frequency array, plus one, of course. So it will have elements 0, sorry, indexes 0 to 7, so its size will be 8. 5, 6, 7, 8. And let me number the index also. 2, 3, 4, 5, 6, and 7. Alright. So now what we do is we traverse the array A backwards. So the first element we encounter is 1. We pop it if you are using stat, or we just can decrement it. I'm just marking a slash over here to keep check that we have already traversed it. So whatever element we get at A, we go to that index in C. So we got 1, right? So we go to 1th index, and we encountered a value 2 over here. So we just at one index we encounter 2. So in the B array, what we do is at 2 index we make it 1, just the opposite. So we had 1 2, we make it 2 1. The value at index 1 was 2, the value at index 2 becomes 1, and we decrement it also. So this 2 becomes 1. Now, no, one was we get to an experiment in A, we encounter 3, so we go to 3rd index, and at 3rd index we encounter 5. So at 5th index in B array, we write 3, and we decrement this 5 to 4. Then at the next element is 0. At 0 index we have 1, so at 1 index we write 0, and we make it 0. Now we encounter 5, so we pop it, check the 5th index. At 5th index we encounter 7, so at 7th index we write 5, and we decrement this 7 to 6. And yeah, we continue this 3 more elements. The next element is again 3. Oh wait, sorry. Yeah, the next element is 3, so we pop it. Now this is why the decrementing is important, because if we didn't decrement it, we had at 3rd index we would encounter 5, but at 5th index we have already put 3, so it will lead to error, right? We won't be able to update it again. I mean, we can, but we should update only the index in B array only once. So yeah. Now we encountered 3, right? So at 3rd index, now the updated value we have is 4. So at 4th index, we write 3. And then we decrement this 4 to 3. It's getting a little messy. Let me just remove this and write 3. So yeah, okay. Yeah, so now two more elements. At next is 5. So at fifth index we encounter 6. So at sixth index we write 5 and decrement it to 5. Here also erase and write. Last element. So last iteration with the last element is 2. So at position 2 we encounter 3. So at third index, sorry, at index 2 we encounter 3. So at index 3 we write 2 and decrement it. And since we have traversed the whole array A, we can stop right here. Now you can observe that the output array B, is same as a sorted array 0, 1, 2, 3, 3, 5, 5, 0, 1, 2, 3, 3, 5, 5. So this was a counting sort. Hope you guys enjoyed, and yeah, best of luck for keep learning. Bye guys.